Let's take a look at a few more examples of solving quadratic equations. Number 2, we want to solve the equation 9x squared equals 16. And so the first thing that I could do is to solve this kind of using the square root property. So try to isolate x squared, and then we'll take the square root of both sides. Okay, so to isolate x squared, divide each side by 9. Okay, and we're left with x squared equals 16/9, and then take the square root of each side. And we are left with x equals plus or minus the square root of 16/9, which simplifies to plus or minus square root of 16, which is 4, over the square root of 9, which is 3. So plus or minus 4/3. Another option is to move both terms to one side. So 9x squared minus 16 is equal to 0. And notice that this is a difference of two squares. So we're going to find factors of the form x minus b times x plus b. In this case, take the square root of 9x squared, and that's 3x. And then the square root of 16, which is 4, and then one of these will have a plus and one will have a minus. And now you can just set each of these factors equal to 0. So 3x minus 4 equals 0, or 3x plus 4 equals 0, and isolate x. So the first equation, we get positive 4/3, and the second equation, we get negative 4/3. Okay, this next equation is 6x squared plus x minus 1 is equal to 0. We're going to try to see if factoring is possible. And then if not, we'll use the quadratic formula. So one option for factoring a quadratic trinomial, especially with the leading coefficient something other than 1, is to use the guess and check method. And so the first two terms should multiply to give us 6x squared. And so we have a couple of options for that. We could have 6x and x, or 3x and 2x. So you kind of just have to go and try and then test them out. And then the other two terms should multiply to give us -1. And luckily there's either just a +1 and a -1, or the -1 could come in the first factor. So we just have to decide which one is correct, if this will even work. And to do that, we just need to check the middle term. So the middle term would be, let's see, -3x plus 2x, which is -x, not positive x, okay, which is what we need it to be. So if that didn't work, let's change these and put the plus second and the minus first. Let's see if that works. So that's 3x minus 2x, which is definitely positive 1x. And now we can set each factor equal to 0. So 3x minus 1 is equal to 0, or 2x plus 1 equals 0. And isolate x. So in the first equation, x is 1/3. In the second equation, x is -1/2. And that is our solution. -1/2, 1/3. Well, another option for factoring is to do something called factoring by grouping. And to do this, we first take the product of the leading coefficient, 6, and the constant, -1. So 6 times -1 is -6. And you find factors of -6 that add to give us the middle coefficient, or whatever b is. In this case, it's 1. So we'd have 3 and -2. since the product is negative 6, but they add to give us 1. And now we're going to just replace this middle term. So we bring the 6x squared down, but instead of having plus x, we have plus 3x minus 2x, and that way it still is equivalent to the original quadratic trinomial. And this is when the grouping begins. So split the expression in half. Factor out the greatest common factor from the first two terms, and that would be 3x. And then we're left with 2x plus 1. And then whatever that next sign is, bring it down. And we see that they don't have any common factors other than 1, so negative 1 is what we're going to pull out. And then we are left with 2x plus 1. And notice at this point, these two binomials in parentheses, they should match one another, which they do. So that's a common factor, 2x plus 1, and what remains is 3x minus 1. We could then just substitute these factors into the equation, so we have 2x plus 1 times 3x minus 1 is equal to 0, and then set each factor equal to 0 and continue to solve. And then this last example, we're going to try to solve this equation x squared plus 6x plus 13 equals 0. And so the first thing that I would just test is if it would factor nicely, and we want to find factors of 13 that add to give us 6. But our only choices, since 13 is prime, are 1 and 13, and that sum is not 6. So we know that this is not factorable. But another thing that we could do as a test, if it wasn't as obvious as this problem, is to find something called the discriminant. And the discriminant is part of the quadratic formula. Okay, and it is the part that's under the radical, so it's b squared minus 4ac. And if we get a perfect square, then we would know that we could factor the quadratic. Okay, so let's just do this test really quickly. And so b in this case is 6, so 6 squared minus 4 times a, which is 1, times 13. And that gives us negative 16. Okay, so there's a little bit of a problem because this is a negative number. And if that's the case, we're going to find a non-real solution, or not two non-real solutions. They're going to be conjugates of one another. Okay, so the discriminant is just a helpful way to kind of determine what your solutions are going to be before you even begin the problem. Okay, but the quadratic formula will always work. And so let's try it with this problem. We have x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so that gives us negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 13, all divided by 2 times a, which is 1. And now we have negative 6 plus or minus. We already made this calculation, the radicand, and that was negative 16. So the square root of negative 16 divided by 2, and that's negative 6 plus or minus. Okay, here's where we needed to use our properties of non-real or complex numbers. And that tells us that the square root of negative 1 is actually I. So I can rewrite square root of negative 16 as just 4I divided by 2. And then lastly, 2 goes into negative 6, negative 3 times, plus or minus, and 2 goes into 4, 2 times, and don't forget the I. So negative 3 plus or minus 2I are the final answers. Notice there's 2 of them, and they are definitely conjugates of one another. If you want to write them out individually, one of them is negative 3 plus 2I, and the other one is negative 3 minus 2I.